Very nice. Thank you, guys. So, how is everything going? How is the weather in India right now? Is it now winter is behind us, or
Yes, sir.
you have nice spring there now?
Nice, sir.
You guys, you guys can enjoy it. Morning walk, evening walk, sports. So, what's new? Earth, you watch a lot of cricket. So, what's going on? I heard that there were a lot of recently international matches. How did the India do?
So India do very well like always.
Yeah. Okay. Did it win all the matches? Can
Yes,
you tell us?
sir. Till today there are two matches now. For tomorrow it will be the biggest match like India versus Pakistan.
That is tomorrow.
Yes, sir.
It's on Sunday. Okay. Where is that play will happen in Pakistan or in India?
Sir, the T20 World Cup is holding at like India and Sri Lanka. So it will be happen in Colombo because Pakistan is not ready to come to India for playing any match. That's why Bangladesh was out of T20 World Cup because they don't want to come to India.
Oh, okay. All right. Very nice. All right. So that's the small. Always we like to start a little bit with small talk. That's the American way. Don't start just like high level of science or so. That's good. Shreya, do you have any small talk to do? Anything you want to share? Any news about you or
Sir, I am Parth,
your
sir. It is my sister account, so you are telling Shreya. That's why, sir.
what is your name?
Parth, sir.
Parth. Okay. All right, Parth. So, do you have anything to share?
No, sir. Much
Anything you want
recent.
to talk about before
Yes.
we start talking about science? This is like first 5 minutes is like while people are assembling, they are still coming. Mallik is not here yet. We're waiting. So, we can start a small talk. That's kind
So
of warm up.
I
Warm
think,
up.
sir,
Haha.
Parth is first time. So Parth, can you
Yes.
say
Yes, sir.
something about yourself? Yes.
Introduce yourself, Parth. Say your
My name
name.
is Parth. So my name is Parth. I am from India, Bihar, and I'm studying in Holy Mary School in the Earth School.
Oh, good. So you must be an Earth friend, huh? Okay,
Yes,
good.
yes, yes, yes.
You guys should bring a lot more friends. Why don't it's a very good meeting here every Saturday, and that way your friends can get together also. That's what we encourage you because when you have several friends, then you learn more. Yeah, so you
Yes,
try to tell all your friends about this meeting that hey, let's go all together and enjoy together this meeting. We are not going to give you too much homework
yes,
here.
I do agree, sir. I do agree.
Yeah, yeah. So don't worry about too much homework. We give you guys homework, but it is like optional. Whenever you are ready, you can answer that homework. So
Sure.
it's not like it's deadline that tomorrow you have to do it. Good. All right. So welcome to you, Parth, for coming today. And Arth, sometimes your cousin used to come. What happened to him? He stopped coming from Delhi.
No, sir, he will come like he's busy. I will call him today and ask.
Yeah, tell him to join. It's good. I mean, what can be better for a student like you guys to join meeting like
Yes,
this?
sir.
Okay, so that's very nice. Now I see also name Rakesh Jha. Um, can you
Sir,
please?
I'm yeah.
Okay, please introduce who is with Rakesh Jha. What is the
So
name of
he's
that?
Sakshi. He
Huh?
has joined several times.
Oh, who is it? Saksham.
Action, yes, sir.
Oh, okay. Yeah, he's the veteran now, like Aryan. So,
Yes.
right now, Aryan, Earth, and Saksham. These are the three veteran students we have. So that's very nice. So, yeah, I don't know if there is any way in this meeting we can show the real name of the students. You guys have to explore in the Google Meet and see if there is a way. rather than showing your parents' name, your name can display. So that is another computer science homework for all students. Okay, figure it out. How can we have your name displayed rather than your parents' name?
Yes, sir, we can
All
do
right.
it.
Yeah, yeah. We know that we want it to have your identity, not your parents' identity. We want your parents to be known by your great work. Okay, that's the
Yes,
new work. For example, I give you like before Dashrath ji was known because he was a great king. But when Ram became king and all his Ramayan, everybody knows Dashrath because of his son Ram, right?
yes, sir.
So same way, if you guys do a great job, then your parents will be known. Oh, so and so is the dad of say Aryan or Earth or Parth or something like that. Okay,
Yes,
so that's what we want. Our goal is to improve you so much that you something great in your life. Okay, all right. So I think that's the introduction part. Small talk done. Now let's go to the science session now, and let's see if anybody has any interesting thing to share of the this week in science, and also anybody wants to share anything from the previous homeworks. We have bunch of homeworks due, so that, or if not that, then something new if you guys want to talk. So who wants to go first? Raise your hand. All right. So Saksham, you want to talk first? So go ahead.
I have a question that how the electricity is produced.
How is electricity is produced? Okay. Okay.
Yes,
So
sir,
okay.
with the
So
lightning.
yeah. The first thing is that you know the what electricity is, right? I mean, people have known electricity for very long time because of the we have the rain. We have whenever we have the rain, we have cloud, and there is thunderstorm, and then suddenly you have some lightning, right? And so people have been knowing about it for a very long time from ancient time, but we were not able to really utilize it very well because we had no control over the thunder. Thunder is full of energy. Now you can utilize that thunder to convert that into electrical energy or mechanical energy. But our forefathers, since civilization growing year after year, they didn't have this very well understanding. Okay,
yes,
now so let's come to modern world, and so this has happened all the way until last century. Until last century, like I would say 18th century, not last century, 18th century, we were not we haven't much made much progress in this area of understanding electricity. Okay, but then in that century, in 17th 18th, I would say the more, a lot of science development happened. There was a lot of scientists like Faraday's and many others. They started talking about electrostatic. They came up with the laws. You will hear and read about them in your science class very soon. So all that started. So basic electricity knowledge started happening. Then in the last century, like 1900, you can call it not 1900, 1860 and onwards. There were serious work done in America. There were different companies, and they were able to come up with ideas. How can we convert, how can we make electricity? So there are two ways you can do. You guys already know the mechanical energy and electrical energy and all other kind of energy. So and then you will learn in the later on that what we call it, that energy is pretty much constant, and you can convert one energy into another energy. So basically, two things happen in the I think 18th or 19th, I'll call it combined centuries. that they started working that how to produce electricity. Two ways they came up with the ideas. One was in the lab, how to create the electricity, and other one was that how to harness energy from the existing energy source. So I'll first talk about electricity generation. They started about basically figuring out from your basic electronic math that uh, there has to be a source, there has to be a drain, and then there has to be a gap between source and drain. Just like if you have seen any small breeze in the village areas, you will see that there is a sluice gate in the bridge there, and then one side is for the if you have high water, then high water in the flood time, you open the sluice gate and it goes to the other side, low area. Similarly here, what I'm trying to imagine is the source is that one side of the bridge, and drain is the other side. Name explains itself, and then you have a gate. Okay, so gate, they converted that into what you call it, channel width. And so basically they come up with the ideas source and drain, and then there is a space in between. And then they said that how can we do something that electron can move from source to drain. And they figured it out by different methods, and that is how they created the electricity in the lab. Okay, so electricity in the lab is nothing but flow of electron from one place to another place. You keep, I mean, if you look at all this thing, so it is electron flow basically. So that was done in the lab on the smaller scale, and from that small scale, it further developed, and then it is first started calling it a DC current, direct current. The DC current was the first thing done by Westinghouse in the United States, and then DC current was the first. Then they say that well, DC current has a problem that as it goes from one point to another point, let's say if you have to go half a mile, the current density reduces. It dissipates in the air some of its energy. So let's say for in other way, if you started with say 10 kilogram of energy, by the time you go to the other side, you have only 5 kilogram of energy left. Just I'm giving you one example. So, so that was DC current. DC current was, the problem was that you can use it for electricity, everything, but over the time, electricity dissipates. And interestingly, even in your car, the battery which you have in the car or in motorcycle, that is based on DC current. So DC current has a big problem that you have a limited distance it can travel. But that world was growing. They wanted, say for example, create energy in say in Mumbai, and suppose if you want to take that energy all the way to the Assam, you couldn't do it. So that is when there was another scientist. He came with the idea of alternating current, and alternating current is called in short AC. You will learn about it now in the school. So AC. So we migrated from DC to AC. Now in the AC, good thing is that whatever energy you produce at the source, that source you can take the same density or same value will remain at the other end of the destination. Okay, so now you I want you guys to read more about what is DC and what is AC. I'm not going to go into more detail, but that's what DC and AC. And currently what we are using is AC current all over the world. Okay, so that's one. Now, how do we produce? There are two ways you can do it. There are a lot of thermal power plants where you have oil or you have gas, and from there you do a lot of things, and then that gets converted to energy. That's one way. Second thing is that from the water, you have heard of Vakara Dam or many other dams. So where you do is that you from the water, you have in the lake, and then you have a dam, and from the water you circulate the what is called turbines. Turbines is a kind of machine, a fan. So like fans have blades, turbines have blades. So with the heavy water flow, you move the blade, and then when you move the blade, from there you create the mechanical energy, and then from the mechanical energy,
Hello,
you
sir.
guys have learned about electromagnetic so far. So from the mechanical energy, you can convert that into electrical energy, and that is what is called right now the hydropower energy. And then another thing has developed is called the solar energy. Right now, there are so many solar plants. So you directly use your sun so as a source, and sun has heat energy. So you take the heat energy from the sun and you convert that into electrical energy. Okay, so this is the basics. Now I want you guys to do more homework. Read, there are a lot of information on internet these days, so you have general idea. You have two three scientists which you should know about. One of them is Tesla. You might have heard of Tesla car, but he was a great physicist. He is the one who came up with the idea of AC current. Before Tesla, it used to be only DC current. Okay, so Tesla created, and not only that, Tesla is the one who created first hydro power plant, and I and Mallik ji have visited that power plant where electricity was generated. Actually, Mallik ji is here. While Mallik ji is going to talk, I'm going to find one of the picture of uh, Tesla power plant, which was created in Niagara Falls, and I'll share with you. So, Malik ji, welcome back. And I see there is another Satyajit. Satyajit, could you please introduce yourself or any student who is with that name?
Hello, good evening to everyone.
Good evening, sir.
Sir.
Good evening, sir.
Good
Good
evening, sir.
evening, sir.
Yes. So, Satyajit, can you give your introduction? Please unmute yourself. Hello. Yes. No. Pankaj, can you help? Yeah.
Hello, sir.
Yes. Satyajit, you are speaking?
Yes, sir.
Yeah. Please introduce yourself.
Sir, I'm from Odisha, currently in class 11th, and this is
Mhm.
my second session actually.
Oh, you are from Orissa. Which place?
Sir, Kalahandi, it is district.
Oh, very good. Very good. So, you are
Sir.
studying in class 11 in
Yes, sir.
CBSE board?
Yes, sir.
Sir, I know him.
Oh,
Sir, he has joined my classes some times ago. Uh,
mhm.
has taken PCM. We were talking about Lagrangian and other stuff.
Okay.
He's from my group.
So, Satyajit, what are your interests?
माई कौन है आप बोलने लगती हो क्या करेंगे तुम सोए हुए हो
Mute yourself. Your family talk can be heard. You don't want that to be public. Okay. So
Yes,
if you have
yes.
to do family talk, that's the rule. You should mute yourself. And then
Yes.
yeah.
So,
Okay.
so we
Go
have
back.
now one raised hand is there.
Yes, Parth. Please introduce yourself first. Hello, Parth.
So my name is Pashurya. I am from India, Bihar, and it is my first session in the topic.
You are from which place?
Bihar, India.
Bihar, India. But which class?
Uh, Sixth class, sir.
Class?
Sixth.
Oh, class 6. Okay. So, and this side we have, there are two raised hands. Who wants to speak first?
I.
Sir, I have the question that according to black hole information paradox, if a black hole produces thermal radiation, you can say Hawking radiation, and eventually evaporate completely. Then what happens to the thermal radiation and information?
Oh, this is too difficult a question, and I don't know the
So, sir,
answer. Anybody can.
he's talking about the paradox. So it says if something goes in the black hole, what happens to it? So is that information just lost? So that is not true. It gets evaporated. It gets like small parts of it get evaporated from the black hole by Hawking radiation. So then these Hawking radiation just travel in the universe like ordinary particles.
So, Aryan, these are the things, man, what happens in the black hole.
Yes,
All these are not something which is
yes,
well understood.
yes,
So something we cannot say that it will this happen and that happen, because we are still in the process of understanding what happens in the black hole.
yes,
And there are many issues which have to be resolved. But then people, scientists do keep on, making hypotheses that this may happen and that may happen.
yes,
So only then we get to know, actually, we get to know the real things.
yes, sir.
So we will not discuss very hypothetical things because they are not proven. So we'll,
Yes. So, but the sir Hawking radiation is proven. I think so. Stephen Hawking did that.
I'm not very sure right now whether it is proven or not. Yeah, but the Hawking did propose.
Yes, sir. So, sir, we have another question by Parth.
Acha. Yes, Parth, please go ahead with the question.
Sir, I in my one exam it was a quiz competition, and there was a question. What is a pendulum? Pendulum.
What is the?
Pendulum. What is a pendulum?
Sir, he's talking about penumbra.
Oh, penumbra.
Pendulum.
So, are you talking about penumbra?
No, sir. In question it was written a pendulum. What is a pendulum?
No, your voice is
Pendulum.
getting cut. What is, Aryan, are you able to make out what is
Sir, I think so. He's saying pendulum.
Yes, sir. Yes.
pendulum?
Yes,
Yes.
Okay, anything, that suppose you have got a string and you tie a ball with that and then you swing it. It's a pendulum.
yes,
पहले घड़ी में नहीं होता था, घड़ी के नीचे में जो होता था वो स्विंग करता रहता था. That is a pendulum.
Okay, sir. Thank you, sir.
Actually, one of you should do this experiment right now and show us. Let's do the experimental physics. This is very good, easy homework. Can anybody quickly make a pendulum and show us? It's you all should have a string and little tiny ball in the home or something. Show us real time. So that's the homework for any of you to do it. But while we bring that structure, that was your question about electricity. I am showing you the Niagara Falls picture. Do you see that? So I'm sharing with you. So see here, the water was coming from very high height, and then the dam was created. See, this is how it was. Is the fall example of the fall. This is how it looks like right now. If you go, water is coming from very high, and we went at the bottom of this picture, which you see. Me and Malik, she was there one time, and we become wet because of the what you call the vapor. Not vapor is for the hot thing. Mist. The mist. There are so much of mist. They give you a kind of something to cover, but still we were wet. So what you see is that water is coming from very high altitude to the low. So by gravity, it has a lot of energy in it, and that is what was used. They've created a dam, and you see a picture of dam here. This is the dam, and then after that, they created. I just saw a picture of the blade, so I wanted to show you that. Give me a second. It will come here. Where is that? 1 second. Yes. See here, this is what is happening here. That the blades of the turbine, they get uh, rotated by this water energy. See that this one right now, which is showing, and then that's how you once you rotate the blade of turbine, uh, uh, there is a mechanical energy, and then using some other electromagnetic uh, theories, that mechanical energy gets converted into electricity. That's all is happening in the in the in the hydropower plant. Thermal power plant, you can run it but from the coal, and then or the gas. And what you do is, in this case, you you heat the water, and then you create the vapor from the water, and then vapor at the high pressure, just like the steam engine used to run. You use that pressurized vapor to run the blades of turbines. And then again, after that, it is again the same process. Once the turbine is running, you have a mechanical energy, and then from mechanical energy, by using electromagnetic theories, you convert that mechanical energy into electrical energy. Okay, so that is what is the how the electricity is generated.
Sir, someone has some questions.
Yeah.
Yes, Satyajit, what is the question?
Sir, is it the rate of rotation that matters more, or is it the radius they are at?
Yes, rate of rotation does matter.
Yeah, is it the rate of
The-
rotation that matters more, or is it the radius that they are at? Because
Even
if it is
radius,
all
it
about
is
the rate of rotation, then we can just
basically
fix
it
it.
is related to amount of the flux being cut. So the rate at which the flux changes, so the size will matter and as well as the speed will matter.
So having it in our day-to-day life, like let's say in our fan itself that is rotating, then the size would matter, I guess. That's why it's not a good idea.
Sorry, I didn't get your question. In the fan, in the fan, basically you are converting electrical to mechanical thing. And what Amarnath ji has told you is about the from mechanical to electrical.
Cannot we have both going on simultaneously?
No, I do not know what do you mean by that, but yeah, it is if the flux which is there, if the flux is getting cut, so at the rate at which it gets cut, and that is written in Maxwell's equation that how much current will be generated. So
Sir,
you are in class 11, no?
yes, sir.
So in class 11, you must be having already now good amount of electricity.
Sir, electricity specifically is what we have in 12th actually. That is,
Acha, okay, in 12, acha, next year that you had.
sir,
Okay.
my query is, cannot we have both the systems independent of each other and simultaneously going on? Like as you mentioned, we are converting the mechanical energy to, sorry, electrical energy to mechanical energy in our original system, that is the fan and the switch. What I am proposing is, cannot we have, like, this is a query, cannot we have the system that generates electricity in the dams within the fan independent of the first system?
Your next question would be that first, so the system will generate electricity, electricity will generate mechanical energy will generate electrical energy, and the whole fan will be running forever and ever and ever. Is it?
A
Are you proposing
perpetual.
that? Well, the answer is no. There is no, we call it in English perpetual, Perpetual, perpetual. There is no perpetual machine. Means you cannot do that.
Sir, what is the problem?
No, this is a generalized thing that you cannot use. See, once you have an electrical thing going into mechanical and mechanical going into electrical,
Yes.
so first of all, so that means it will be self, it doesn't require anything from outside. That is what you are meaning. So by itself, it will be just running. The whole system will be running. But usually that doesn't happen even in normal and ideal in cases, because there are losses are there. So once there is a conversion is there, it doesn't get converted fully.
Yes, sir.
One is, but people in 16th centuries, not 16th, 17th and 18th and 19th, people thought of doing, having perpetual machines. Means it will be running by itself, but nobody managed to do it.
So guys, you saw this is a very interesting conversation. Uh, Satyajit's question is that can we make a machine which is 100% efficient and it doesn't have any energy dissipation or energy loss? That was his question. Because if we can create that machine, then the we can utilize the 100% source and keep converting from each to another, electrical to mechanical, mechanical to electrical in cycle, and then we can have a machine which can run automatically forever, all energy problems solved. But the problem, Satyajit, is just like Malik ji said, energy dissipation. Okay, when you convert energy from one to another one, in that process, you your energy, some of the energy is lost. Okay, that's why you have not 100% efficiency of the machine, and you have to compensate for that one in the source someplace.
Sir,
But
how about
Satyajit, you can try your luck if you want to make one.
Yeah, yeah. Why not? We all will help you. Yeah.
sir, how
Okay.
about we
Good.
don't consider we don't target for the 100% efficiency, but instead we just make some extra electricity on the go in the process of getting
Uh,
the benefit.
I think like whole automation which is happening in the world right now, the whole idea is how to increase the productivity, right? So that's a very good thought, and we as an engineer and scientist have always tried what you are saying. That is one of our goal, to how to reduce the dissipation of energy or energy loss. So we have improved quite a bit of machines in every area, but we are still not 100% there. And that's why you see that a lot of new materials are coming into play, like palladium, platinum, this, that, rare earth materials, because ultimately what they are doing, they are helping us in the conservation of energy. That's why they are so critical. So yes, there is a room, and maybe some revolutionary theory which you can come up with, which we don't know yet, like
Sir.
Max Planck, something new idea, and it's possible. It's quite possible that we can have 100%, because we all know that energy is constant. It it transforms from one form to another, but
Yes,
if we
sir.
can figure out how to whatever is transforming, if we can what you call recollect that one, like for example when we have a drain in the sink, if we collect that sink water, drain water, uh, we save the 100% water, right? So like that is exactly what you are saying, that whatever is the loss of the energy, how can we reclaim it and reuse it? So that's a very good project for future.
There are
Sir.
some raised hands. Who wants to speak?
Uh,
Anian, you want to speak?
Yes, sir. So, sir, people tried and thought of getting 100% machine efficiency. So, people thought that it should be a 100% efficient system. But the main problem they lacked was the energy was converted into heat because of friction. So the maximum they could do was try to reduce and cut the friction. So that was the least, that was the highest thing that they could to improve the machine's efficiency. Yes,
Very
sir.
good.
Yeah, that's correct. Yes.
And
So this
sir,
is what.
today,
Mhm.
Namaste,
Yes.
Diganta ji. Yes, sir. Today Diganta ji also joined. I think Aryan knowing him, he joined few years before. Yes, Diganta ji. I request you
Yeah.
please say something about yourself. It will be good.
Hello everyone. Sorry, I cannot be on the on video. I'm walking my dog. But hi everyone. My name is Diganta. I stay in Atlanta, Georgia. I work as a HR analytics manager here. My friend got me introduced to this group, and I was very grateful. But then life happened, and I could not be a regular member for almost 3 years. Now life is falling into place, so I'm back here and would love to contribute in any way I can. And I'm glad to be here. Thank you.
Uh,
Thank you for the invite.
Welcome back, and I'm Amarnath from New Jersey, and there are a lot of other people. We have meeting probably since you have joined after a long time on
Uh-huh.
Saturday the same time, and also on Sunday. So Sunday meeting we
Awesome.
have for young professionals like graduating students. We guide them there. So please join whenever, and of course we need here lot more scientists and engineers in the panel, because you see how these young kids are asking tough
Yes,
questions,
yes.
which we learned in our engineering college and PhD, MSc. They are already asking these tough questions. So we need more panel members here, like you and Malik T. So please join whenever you can, and and then also on Sunday we have both days. So whenever is convenient. Thank you for
Awesome.
joining today.
Of course. Awesome. Thank you. Thank
Yeah,
you, everyone.
you're welcome. Please come every time.
I try to. I try to. Like I try to be a regular here and help in whatever way I can. Because yeah, I remember when I was a child, I we did not have scope for questioning. The education system was such that like questioning was not very entertained. At least where I grew up in. But then like seeing everyone question and like think on their own and think beyond boundaries, it's amazing, and that is what is required in today's world.
Yeah, in fact, in our times, if the student used to ask some question, which could be a little bit stupid, the teacher used to get angry
Yes.
and used to shut him
Yes.
down.
Yes.
Yeah.
But I think all questions need to be answered. If
100%.
the child has a question in his mind, then there is something behind it. So we
Yes.
should try to answer that. Now,
100%.
Saksham is having a question. What is the question?
Sir, I have a question that when we cook a chapati, then why does it swell up?
I
Oh
think
my God.
this is somebody else should answer this question. This is a mechanical mechanical question.
Sir, I think
So
so.
Oh, no, no.
mechanical man.
Uday ji is the best person. Uday ji, what is your answer to that?
Sir,
I think there are a lot of students who should be able to answer this question. I think Aryan can handle this question. Aryan, you want to give it a try, or
sir,
even Satyajit
yes,
can answer this question.
sir, I think so. It, it is because the water that was under the chapati, it boiled off and it produced steam, and that steam made the chapati swell.
But
Do you agree?
why only in the chapati of wheat, not in other chapati like chapati of barley, etc.?
I think so because of the moisture content. If they have a lot of water in it, if there is moisture, it will then produce steam, and which will try to escape and which makes the chapati swell. And it happens in popcorns also. So if we have a kernel and there is some water in it, some moisture, and if we heat it, the steam will try to escape it, and we'll get the popcorns we eat. So it is because the steam is trying to escape. So
Are you
sir,
satisfied, or you still have follow-up questions, Laksham?
yes sir. So
Let,
So today I want to ask one very difficult question to all of you. So our young people, maybe you should try to answer, or maybe next time you should answer it. The question is like this: that see, moon goes round the Earth in about 29.5 days. So why we don't get eclipse every month?
Sir,
Is it?
Sir,
Isn't
because
it?
the Earth
Sir, which eclipse,
does
sir?
not get at that position near the sun at every month.
It
Sir,
is
which
not.
eclipse?
Yeah, so both the eclipse will take place because the moon is going down the Earth in 29.5 days. So once it will be between Earth and Sun, then you will get a solar eclipse, and once it will be the Earth will be between Moon and Sun, so you will get lunar eclipse every month. But we are
Sir,
not
I,
getting that
sir,
sir, I think that's because due to the elliptical orbit of the
due to the
Earth,
elliptical orbit. No,
yes, sir.
sir,
no. Saksham, one thing I'll tell you that. So first, in your mind, it came that the answer is elliptical orbit. Now the question is,
No,
why does elliptical orbit allow that?
yes,
sir,
sir.
my answer was due to the
Yeah.
orbit
Yes.
of the Earth when the Earth's moon and the sun come in the alignment,
Hmm.
then due to and if the Earth is in between the moon and the sun, then the lunar eclipse will happen. In
Yes.
this, what happens that the light of the sun falls on the earth, and that light is then reflected back toward the moon in the blue and the red shadows. And if that red shadow falls into the moon, it which is called the umbra, then it is said to be a lunar eclipse.
Sir,
No, no. So I understand. So every month it will happen, isn't it?
sir, I have something to say on this. So,
Just let me just cross question
okay, sir.
Earth. Yeah, Earth. You are speaking, isn't it?
No, sir,
Or
he's
Saksham?
Aksham.
Oh, Saksham. So every month we will have lunar eclipse and solar eclipse, is it?
Sir, I think that
Sir,
mean
I think
the moon's orbit is little bit tilted or something like not exactly at same revolution, round revolution.
Moon. So your answer is what? Moon's orbit is tilted, or moon's orbit is what?
Mean curved. I mean a circle is there. No, mean one time going down, one time coming up like that.
no.
Oh, I say. So that could be that could be any other answer.
So, sir, it is because of the moon's configuration. So it needs to be at an exact place, and most of the times it's up or down. And
No, no. Why it is up and down?
sir, it is wobbly. It's sometimes up and sometimes down.
What do you mean by oblong?
Sir, it's an wobbling motion. It goes up and it goes down.
No, are you meaning that that means the orbit plane of orbit is tilted? Are you meaning that?
Yes, sir.
No, but that is not oblong. So that means plane of the orbit is tilted. So so is that the only answer, or there are some more answers to it?
Sir, like the moon is revolving around the
Sir,
earth.
I think it might be due to the tilt of the Earth.
Tilt of the Earth. Acha,
Yes,
how
sir.
do you explain that? So in science, you don't only have to answer; you have to also explain others. Anything that you say, you must learn how to explain it to others. If I am saying something that it is because of tilt, then I'll explain how the tilt causes this thing. So we just cannot make any statement, but we should make a statement with explanation. So we should think about it. Any other answer?
Tilt of the moon's orbit, sir.
I agree. Tilt is okay. Let this be an task then for the next week? It's a very,
So
very
because
interesting question. Yes.
I think sun also attracts the moon some towards, and earth also attracts because of the gravitational force. That's why sometimes it is going tilted. That's why.
Oh, you're explaining why the tilt happens, is it?
Yes, sir.
Oh my God! But this, your good name, please. Sorry,
Sapat Shaurya.
Parth. Yeah. So Parth, yes, you have got a very original idea, by the way. But you must explain how, why, what it is, because I am
So
not able to
gravitational
understand.
force
You may have to convince your friends that what you are saying is correct.
mean earth is also attracting the moon, and sun is also attracting the moon. So mean in this situation, mean sometimes moon is getting tilted, mean like that, because of gravitational force from the both the side. That's why
Only
like
sometimes only it gets tilted. Other times it doesn't get tilted, is it?
yes, then sometimes the sometimes the greater force, I think so.
No, like the
I have
Earth
much
is
idea, much better
tilted
idea.
permanently towards the sun, like 23.5 degrees. The Earth is permanently tilted. Then also the Moon is also permanently tilted 1.5 degree towards the Earth.
Mhm. Okay, let this be an exercise for next week. I think someone must come with a complete answer. Some of you have given partial answers, so I want a complete answer which you can explain to everyone, even a class 4, class 3 student. You can explain that why the eclipse doesn't take place every month.
Sir, can I
Yes.
give a test?
You want to give, or you want to ask some question?
No, sir. Can I give a guess to the answer of this question?
Yeah, give.
Sir, I think that's because due to the moon's tilt on its axis, which is roughly 1.5 degrees.
So how that affects the eclipse? Eclipse to shadow hai, that much. You see, even Aryabhatta, Aryabhatta in 5th century told that a eclipse is a shadow, but that time, in 5th century, people didn't accept his explanation, but he was correct actually. He was correct that eclipses are caused by the shadows.
So, sir, when the moon is orbiting around it, so
Mhm.
it is not perfect. It is going sometimes up and sometimes down. So it needs to
That
be
is
in.
that is because of yeah, that explains because orbital plane is tilted.
Yes, sir.
Yeah, it is tilted 5 degree. But
Yes,
will that explain this? That why it doesn't happen? Are you convinced about it? That only
yes,
that will convince. Only that will help. Try it. You have got 7 more days to think about it. Are there other questions?
yes, sir. I had one. I had
What
like
is
an opinion giving one. So, sir, I want your opinion on this. So, sir, do you think the
So
universe
I
is
am having one question.
Yeah. Okay, so we will take. Let Aryan finish the question.
okay?
Yes,
So,
Aryan.
so what is your opinion? Is the universe deterministic or non-deterministic?
I mean, if I can answer this question, no, I'll get a Nobel Prize also.
Sir, like I want your opinion on this. What is the point of view?
No, we don't need to have any opinion right now. You see, right now, all along we thought that it is governed by laws, so it will proceed in a deterministic way, provided we know all the laws governing the universe.
Yes, sir.
But suddenly now these quantum fluctuations which happen, they are setting a kind of question mark on this. So, like a universe, a big bang takes place because of the quantum fluctuation. So, a fluctuation can generate a big bang, may not generate a big bang. So, it looks there is something fishy about it. So, nobody knows. This is
So,
a question nobody can answer right now.
So, sir, what I think is that there are laws that govern quantum fluctuations too, but they are very hard for us and we haven't discovered them. So, for me, I think the universe is deterministic.
Yeah, so that will be just an opinion because there is
Yes,
no evidence right
Mm,
now, no evidence to say one way or the other.
yes, sir.
So
Sir,
it is
I
a,
mean,
the
when you say
it,
deterministic, do you mean it's going to have like a predictable outcome, right?
Yes, sir.
An end
Yes,
based on whatever the condition is today or
yes,
in the present, correct?
yes,
Okay.
Can I add one line here?
yeah, sure, please.
Yeah. So if you look at macro level, when we are talking about classic mechanics, that was supposed to be deterministic. But at quantum level, when we look at it, it is probabilistic. So we have moved from what Newton assumed to be deterministic to what we know today. So if you go purely with that particular concept, it has to be probabilistic.
Very much true, Udayji. That's this the present opinion. So now it is left to our young children who will discover whether the universe is deterministic or not. I wish it was deterministic, but then the question arises, then there is no scope for free will.
yes, sir.
So this is a very unfortunate thing, but I tend to think that I have a free will. So if I have a free will, that means it's not deterministic. So it's a very confusing thing, and I don't want to answer, and nobody can answer, right?
So my question is the final outcome deterministic or is everything in between deterministic? Because if we have free will, everything in between can be non-deterministic, but the final outcome is which is the end of the universe that is deterministic.
So, uh, let me give you an example. So the climate is most of the times predictable, but the weather is not. So it is because of some small things that may happen which may turn the weather horrible or very good. So that is my view on it.
Mm.
Oh, no, no. I don't think what Udayji told is the correct interpretation. In case of climate and weather, simply because I can't track all the molecules, so I
Yes,
cannot predict the after knowing the weather at one place, then I cannot predict the climate because I have a limitation that I can't track all the molecules how they are going to behave. So it is the insufficiency of the tools that we have. So, but still it is deterministic. If someone who had a huge computer and knew all the molecules of the atmosphere, then he could say what is going to happen. So,
Can I?
yes, Udayji, yes, please.
Yeah. So I remember someone told me long time ago, decades back. They said that weather is exact science, but the number of variables are so many, is
Yeah.
humanly impossible to factor in. So the first supercomputers came into to predict weather. Now also the biggest of the computers, the most sophisticated, is trying to predict weather, but still is not able to handle all the calculations required. So it becomes probabilistic because we have no way to factor in so many things happening together, and it defies the basic logic of that you must try and factor in as minimum variables as possible to predict anything, because the more variables you involve, they are going to clash with each other, there will be correlation with each other. So that is the dilemma, and as of now we are still trying to understand the weather.
Yeah, Uday, you are very correct. No, actually, one means our inability to predict something is because we don't have sufficient tools. But the other is the quantum mechanical thing where it says that if there is a cat in a box, then we don't know the cat could be there, cat may not be there.
Yeah,
So,
yeah,
and that is a fundamental thing. So, there it is not that the lack of calculation, but it's by the quantum mechanics says by nature it is so. So, there is a subtle difference between the two. One is the absence of tools that we don't have, so we can't predict. So this is what my thinking is. Maybe you could add anything to it.
sir. Sir, Saksham has a question.
Yeah, Saksham, please go ahead with your question.
Sir, Sir, as we know that the friction increases the temperature, right?
Yes, because it generates heat, so it raises the temperature.
Yes, sir. So how does
So,
the so we also know that the environment near a quasar is gaseous. So how does a temperature near a quasar is extremely high?
so Saksham, you have to tell me first, what do you mean by temperature and heat? What is the difference between them? What is heat and what is temperature?
The
So
the
when you
heat.
ask this, you ask this question, no, so you first you must have in mind what do you mean by heat and what do you mean by temperature? Are they
The
two same? Are they two same?
no, sir. The
What is
heat
the difference? What is the difference?
the heat is basically determined as the hotness of the any object. Heat can only measure the hotness of the any object, but temperature can measure both hotness and the coldness, unlike heat.
Saksham, I appreciate your answer.
Sir, heat would be like the movement of these particles, and the temperature would be the measure of a heat. So if it is like say 100, so it means that the particles would be at this temperature and they will be oscillating this way or that way, I think so. That is the difference.
Any other answer? Who else wants to answer? What is difference between heat and temperature? Satyajit, you must have already read now heat and temperature. Do you have any answer? Hello, Satyajit. Oh, Satyajit is out of reach. Who else wants to answer?
No, no, Satyajit is available. Hello, Satyajit. Please unmute.
Sir, can I give a guess?
Yes. So yes. Okay. Until yeah. Please give your guess.
Sir, so heat is the transfer of the thermal energy, but the temperature is the measure of that energy.
More or less, it is correct. More or less, it is correct. Any other answer?
So sir, what is the correct answer then?
So
So can I
temperature
take
is the mean surrounding weather of our
Mhm.
environment, and heat is the hoticity of any object, substance, or anything.
so can I?
Who who has raised the hand? Sorry. Who?
Yes, Earth.
Earth has raised. Yeah. Yeah. Earth. Please go ahead.
So heat is a form of energy while temperature is a measure of how hot or cold a substance is.
I think more or less. Let us accept this definition. Actually.
Well, can I add
Hello.
one line here?
Yes. Please.
Yeah. If you boil water in a cup, it will have a very high temperature, but it will not have as much heat as an ocean, because ocean has too many particles. So the heat temperature only measures the kinetic energy of that particular water, whereas heat measures the kinetic and potential energy. That means the more number of particles, it will have more heat, even if the temperature is low, is less.
Yeah. Did you hear? So all of you understand what is kinetic energy?
Yes, sir.
Who can answer what is kinetic energy?
Yes, Parth.
Who is raising the hand? I'm not able to see that.
Sir, I had another question.
No, no, first of
Let
all.
us finish this one. What is kinetic energy?
Yes,
Uday ji
Parth.
just now told you
Parth.
about kinetic energy. What is kinetic energy?
So it is the energy an object possesses due to its motion, and while static, its potential.
So can
Okay.
I?
Yeah, who else wants to answer this?
So I, Earth.
Sir, me too, sir.
Please
So
also give us
kinetic.
examples. We want to see a couple of examples of both energy.
Okay, sir.
Sir, kinetic energy means the mean temperature or position of any moving object.
Sir, kinetic energy, the energy an object has because of its motion, anything that is moving. It's not depend on how big or how small it is. It has kinetic energy.
Yes. Every object on the world has a kinetic energy.
Yeah, yeah, the actual formula is half into mass into velocity square. That is what kinetic energy is. So now the question arises that the earth is rotating and you are standing on the earth. So you are also moving. So do you have a kinetic energy now?
Yes, sir.
Yes, sir.
Oh, you have a kinetic energy. Okay. Acha, Aryan, you want to ask? The question you are asking?
So, sir, I think so. I have already asked this question, but I forgot about this. So, sir, can you remind me what was the difference between potential and potential energy? Sir, I think so. I have already asked this one, but I forgot.
No, let us say in case of electric field, we say that it is the means the uh, how this potential, the electric field is defined by the how the potential is changing with space. Its rate of change with space is the electric field.
Okay, so, sir,
So
what?
every point has a potential about it. And
So,
I simply want to understand your question that what is it? Udayji, are you able to follow his question?
I think last time we discussed about this particular thing when we
yes,
Yes.
sir.
say that potential is basically the work required to move charge from one to another, and potential energy is basically the total energy that charge has. So
Okay.
it will be actually uh, if you look at the work, it is going to be the or potential energy can be considered as a force, and the charge potential could be considered as a work.
So, sir, if I give an example for in space, so if I have an object, the sum of the energy of its gravitational field will be called its potential. And if I have two objects, and if we add and if they do work, then that will be called potential energy. Is that the case?
Potential energy is to dealing with potential is dealing with charges, work required to move from one to another charge. Potential energy will depend on um,
So, like, sir,
when we talk about the heavenly objects, it's talking about three things: mgh. Okay, so there are three things, that is the mass of that object, at what height it is, and acceleration due to gravity, whichever object you are looking at.
so, sir, potential would be a single body, and potential energy would be a double body. Is my perspective correct?
Potential is generally used in terms of electrical charge. It's not used in case of heavenly objects.
Say also in case of mass also, yeah. In gravitational force also, yeah.
So, sir, is my perspective correct? Like potential is in a one body, and potential energy is in a two body system.
That is the line I'm not able to understand. What is the meaning of single one body and two body in this?
So, sir,
But
like,
what Udayji has just now told you, that between the 2 points, if there is a potential at one point is V1, another point is V2, then this, if I take a unit charge and move from V1 to V2, the work done is going to be the difference of the potentials for a
so, sir,
unit charge. And if it is a multiply charge, then multiply it by charge. So that is the work done. So that is where it comes. So the potentials are defined in that way.
okay, sir. In if I talk in gravity, so the potential would be just the energy
In
of
case
that,
of gravity, the mass comes into the picture, yes. So unit mass going from one place to the other place. So
and
the difference is that. Like
so
say mgh. So here h is what one understand that v1 is at the h means from the earth, at the earth ground level, where we consider say h is zero, means the potential is zero. I can define any point as a zero potential. So I choose that let the earth be the zero, and
mm,
whatever is the height, so I multiply it by mgh,
okay, sir. So, sir, then potential energy.
which is the work done basically, which is
Yes.
basically the work done, which Udayji just now told you. Yeah, this mgh is the work done. If
So,
going from potential at ground and going to another potential at height h.
okay, sir. So, sir, does that mean that in one body system it would be potential, and in a two body system it would be a potential energy?
Now, I'm not understanding this question. That is why I'm not able to answer. Where there is a body, one body and two body come into it. No, why don't you have something in your mind? Why don't you say it? Where does one
So,
body
sir,
and two body comes into picture?
so, sir, the
It is just a potential is how to the rate of change with space of potential is the and multiplied by whatever quantity mass or charge. That's the work done. That is what it is
so,
by
sir,
definition.
that was the definition for potential.
Yeah, for a unit charge.
So, sir, it
So
only required one object, and if we had two, so they can revolve around each other and do other things. So, will that situation require potential energy then? Like,
Aryan, I'm really sorry, I'm not able to understand your
oh,
question.
sir, let me put it that way. If we have the Earth and there is an apple, so these are the two body systems. What would happen?
Yes.
The apple would come crashing to the Earth. So that would be a case of potential energy, right?
Acha, now let me clear one doubt. The earth, apple will come crashing to the earth,
Yes.
and apple also applies the same
Yes.
force to the earth. So earth will also is getting crashing into the apple.
Yes, sir. So is that case of potential energy correct?
No, no, that's very correct. Actually, it
Okay,
comes
sir.
by the potential only. Actually,
Okay, sir. I understood it.
see, actually we think that because apple is a small mass, so you are able to see, but the earth also is getting. See, the force which gravitational law says is constant into m1 into m2 by r squared,
Yes, sir.
where both comes m1 and m2 both come. So the force with which apple is attracting the earth, but earth is so massive that the acceleration due to gravity is very less, and apple is so small that g is the acceleration is large. So you are able to see it, but you are not able to see the earth moving towards the apple.
Okay, sir.
Can I make another attempt and I
Yeah,
don't know whether
sure,
it
sure,
so
sure.
potential and potential energy are two different things. So
Yes.
potential is basically potential energy per unit charge.
Charge. Okay, sir.
Okay.
Yeah.
So you have one charge, you have some potential, you multiply that, it becomes potential.
Okay, sir.
Did I manage to convince you or you got your answer?
So, sir, sir, it's still in my mind. So that potential is for a single body and potential energy is for a double body.
What the, it has nothing to do with body. Potential is uh,
The
I
energy
told you
that
potential is basically, yeah, it is the potential energy per unit charge. So there are, I'm just making a number, 100 charges. So whatever the potential energy is there between those, now you divide them by 100 to get your potential.
okay, sir. So I think so. Someone else has a question to Earthraj.
So, okay, let me also add one more to this only.
Okay,
See,
sir.
if there is a gravitational force working somewhere, so in that force, if you move from one place to the other place,
Yes, sir.
so basically you are moving from one potential to the another potential. So that's why the concept of potential becomes very useful actually.
So, sir,
That is
there.
how it has come.
Okay, sir, there was
So
an.
work done, work because in a force, whenever there is by Newton's law, you have whenever there is a force acting, if something moves because of the force, it does work.
Yes. So, sir, I have something to say. So, there was a person, Leonard Euler. So, what he did,
What was
he
his name? Leonard?
Euler, Euler.
Acha,
So,
Euler, yes. He was
so I
also
think
in mathematics.
yes,
Yes.
he did something for gravity. He created the well diagrams. So he imagined that there are points in space, and each point is marked by some numbers. And if there is an object, it would sink down, and that is the well diagram. So that I was reading about. So that came in my mind. It was also about potentials.
Mhm.
So yes, sir.
Okay. Now there is another question from Earth. Yes, Earth, go ahead.
So the another name of kinetic energy is
Yes. Saksham also has a question, and another name of kinetic energy is what?
He's asking. I think so. He's asking me.
Another name for kinetic energy.
yes sir.
No, kinetic energy, the energy carried because just because of its motion.
So sir, there is any another name for kinetic energy?
I don't know. I don't know. I do not know.
You can
So,
call it motion energy.
so Arthraj, let us just understand the kinetic energy a little bit from your cricket. Say, for example, it is the same ball, and at one time you are making chauka, and another time you are making chakka, right? So, so from the two, this uh, it is the same ball. What makes it different?
Sir, I think kinetic energy, that synonym, sir, we can tell that is we can tell that motion of an object.
So it is the motion of the object. That's correct.
Yes,
But
sir.
it has also some other component in it, like gravity, mass, and motion.
Velocity.
Yeah, yeah. So another example I give you is two body system, which Arjun was telling, which we are not able to comprehend. That Arjun, let's say, suppose you are on the three-story building. Three of your friends are on each floor of the building, and Earth is on the ground, and all three of you just drop a ball. Do you think they will have a different energy when it comes when I mean when Earth has to pick up that ball? You will have to face the three different energy or the same one.
Means
Uh,
I don't understand the question properly, sir.
Okay, so if you drop a ball from third story building,
Yes, sir.
right? So when it comes on the ground, it will make a what you call um, uh,
Bounce.
yeah, it will bounce or it will make a depression there on the ground. If
Yes,
somebody
sir.
is there, it will hit him harder. But suppose if you are on the second story building, it will hit harder less, right? And if it
Yes, sir.
so so what I'm trying to say is that ball has the energy, but because of the distance it is falling from, you have different level of work being produced at the ground. So if earth is on the ground, he will feel different way if the ball is dropping from the third floor or second floor or the first floor to him when he is trying to catch it. And this tells you the example of the kinetic energy.
So
In
the
all three
easiest one will
places.
be first story building because the pressure, gravity that attracts the ball from the second floor, first floor, will be lower than the gravity it will attract from the third floor because of its height.
uh, I think let's leave gravity alone. It is because of the what you are trying to say is the difference of the height, right? That is what it is.
Yes.
The gravity part. Let's say that there will be a little bit of difference, but let's say that they are constant. If I leave that alone, then what is the other factor, which is the distance, right, or the height? And because let's say that the mass is constant, gravity is constant. The only variable here is your height, right? So because of the
And
different
the
height, you
speed
have different kinetic energy.
and the speed also matters, sir.
Exactly.
If the third story, if we third story person hits the ball very hardly, then it will be more harder than the fourth story building.
Here you go. So I
So,
hope.
Shreya,
Yeah.
I have one question. So suppose I have a football and a cricket ball, and I throw it from the 10-storied building. So
Yes.
which will come to the earth earlier and which will come
Uh,
later?
Sir, what
I
is your
think cricket
question?
ball.
bat. So I think cricket bat because it is heavier.
Cricket ball, man.
Cricket ball will come first,
Yes,
will
Sir, can you
land
please
bat.
first.
repeat your question?
No,
Yes,
no. I mean,
bat.
there is a cricket ball and there is a football. And I throw it at the same time from the 10th story building. And which will reach the earth, means ground level first.
So it depends on the wet.
Sir,
If the wet is higher, then it will reach first. If it is lighter, then it will reach late.
Sure. Try it someday. Who else can answer this question?
Sami, Sami.
sir, I think it depends. The ball is of which type. If it is a plastic ball, then obviously the football will drop first.
Yeah. So let me take two examples. If I have a metal ball and there's an other ball, ball A, and ball B is 10 times heavier, so its resistance to motion to the ball B has its the
Acha, okay,
resistance.
let us neglect resistance. Then what happens?
So like so if we try to push ball A and if it goes 10 meters and if we push ball B and if it goes 1 meter, so what is happening? It has more resistance to motion than ball A, and when they fall, what happens that they will fall together because gravity is applying more pressure, but the pressure is getting cancelled by the uh, by the ball's resistance to motion, and gravity
No,
applies.
no, Aryan, I'm asking that you neglect the resistance, air resistance.
Sir,
Then
I'm
suppose
talking
there is no air resistance.
there is no I was not talking about the resistance.
So which will come first, the red ball or the football?
So they will fall together and they will hit the ground at the same time because of the equivalence principle, the
Earth,
inertial mass.
background sound is coming. Earth, when you need to talk, in that time, unmute. Otherwise, yes.
So Aryan says that both ball will fall at the same time. What do you think, Shreya? You are saying that the red ball will fall first.
So it depends on the wet, sir. Wet.
And what
If
does
wet, the
Earth
red
say?
ball.
Earth say, Earth, will the two balls fall together or at different times?
I think different time.
So Aryan, two
It
of your
depends on
friends are
weather.
not agreeing with you.
Okay, sir, let me give them an example. So if I have a metal ball and if I try to push it with, let's say, 100 power, and it only goes 10 meters, and there is another ball.
No, 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 no. You're not giving any power. I'm just releasing from the hand. I'm catching in the hand two balls.
No sir,
One is football and one is red ball. I'm just dropping it, leaving it. I'm
From
not
10th
adding
floor.
any power to it.
From 10th floor, means height, from height.
Yes, yes.
no sir, let me give an
You will
example.
be surprised that this experiment was done in 16th century because people there was a lot of confusion. So we are discussing 16th century science.
So they will fall at the same rate because gravity is applying a greater force at the heavier ball, and it is getting perfectly cancelled. So that is called gravitational. It is the relation between gravitational mass and the inertial mass. They both perfectly cancel out. So if gravity pushes and the heavier ball 10 times more, so it will go the same as the a ball which was uh, lighter than that.
But
So
if the but suppose if there are two balls and one ball is made up of titanium and other is made up of platinum, and if we are falling it from 20-story building, then who will fall first?
if there is no air resistance, and if the platinum ball is heavier, what will happen, that gravity will apply same greater force on that, and it will cancel out, and they will fall at the ground at the same rate. It's about gravitational and inertial mass.
So Shreya, I think, and Earth, um, Aryan is correct. Both the balls will fall at the same time. But till 16th century, people thought that the heavier ball will come first and lighter ball will come late. But then they threw it from a big tower in 16th century and it came down at the same time. How will you explain now?
I don't have any idea.
Yeah, so you have got to read it about it, and maybe next time you can raise this question once again if you haven't answered this question. The hint is that what Aryan has said that both the balls will come at the same time. So how do you explain it now? So Pankajji, is it time to say goodbye to all of our kids?
Yes,
Uh,
yes, sir. 9:27. Yes, yes.
yeah.
Kids, you have any question? Or okay for today?
Saksham
Acha,
has.
Saksham has a question. Yes, go ahead.
Sir, I have one final question which I wanted to ask, that does the friction occurs in gases?
Short answer is yes.
Then what was the question?
My question was that does the friction occurs in gases?
Yes. So they happen in gases too.
If yes, then how?
So it is because of these molecules, they interact and they get deflected. So that is how friction arises. So it happens in all of the three states of matter: solids, liquids, and gases.
Okay, but why only in three states, not in other states like plasma, BEC?
So it is, if the molecules are colliding, if then friction is getting involved. So in other states of matter, it could be, if there is collisions of molecules, that may happen, that will produce the friction, right? So Malik sir, what are your views on it?
Yeah, anywhere where there is a drift velocity, so there is going to be friction, even in plasma.
The Arthraj has a question.
What is that?
So, like Aryan said that time that we when we throw a ball from same time from same height, then
Hmm.
they both will come at the same time. Then
Right.
if we throw a cricket ball and football, then we have to ignore air resistance, to both ball hit the ground at the same time.
I agree. I agree with you. If there is air resistance, there will be a difference will come up. But if there is no air resistance, both will come at the same time.
And
So,
so if there will be air resistance, then which will come first?
Yes. Now, so Aryan, you answer this. He is asking you that if there is air resistance, then what will happen?
so the smaller ball will go first. Then I think so.
Then cricket ball.
Yes, the smaller ball, the cricket ball will hit it first. So I think so. Someone has raised their hand. Saksham has raised. I think so.
Yes, sir. So the answer which Aryan gave some time ago, I'm not satisfied with that answer.
Aryan, so he is not satisfied with your answer.
So sir, sir, how it goes is like, if a person is heavier to move, uh, if he's two times heavier to move than a normal person,
No, not that one. That one that does the friction occurs in gases. Your explanation was not satisfied by me.
if the interlocking of molecules happen, what would happen that friction would be generated. I think so. That's the case. What are
What is Aryan? What is interlocking?
so like if they interfere, they block each other. If the collisions are happening, that would.
Yeah, collisions is the right word. Yeah. Yes.
So, Saksham, what is your argument against it?
My argument is that when the friction occurs, most per- like the when the friction occurs, the temperature increases, and in many cases, sometimes sparks occurs. But in gases, sparks don't occur. So, how can these frictions would take place?
So, sparks do not occur in water, and when we walk, so why does is spark necessary? When we walk, there is no spark. So, in water, there is no spark. Is so spark? I don't think so. It's necessary for proving friction. Okay.
Udayji, our children, they have got a lot of interest in friction.
So,
Yes, and they have very good knowledge about things of explanation also.
Yeah, it's very interesting. Yeah, good. So let us call it a day today. And next time you are coming with the answer of those two questions.
I'm just curious, does everyone here use AI nowadays? Chat GPT, any of those agents? For the kids, I'm asking.
Yeah, do you all use AI? Diganta ji, is it that you will, can you help our children to learn also AI a little bit?
Of course, of course. I'm in that analytics field. I have a computer science background, so I definitely love to help. Like because it's just like the way it's moving rapidly. It's insane. I think India is a bit lagging behind in innovation when it comes to AI. We are using AI to reach our goals and means, but then like especially US and China are progressing at a really fast rate. And the things that are happening right now is it's amazing. I think in the next 2 years we are close to something very revolutionary, almost like the internet boom. So it's happening at a quiet pace, and the only dangerous thing is there's no regulation around it. So I don't know what the world will look like in the next 5 to 10 years. But yes, like it's a friend if you can use it to your own advantage. AI is a friend. So I'd highly encourage everyone to get into any of those chat agents. I'll see if I can get a subscription kind of thing. I'll explore that option so that like you can use it. I'll update later on once I explore more on it. We get it from our like companies we work for. Like they provide us. I have my own personal subscription, but all these questions, I think, like, again, AI should not be the like go to all, but then it gives a very good perspective with examples, with diagrams. Like you can like go deeper and deeper into your questions and inquisitiveness with AI, and they do a really good job answering all those questions.
So, is it possible for you that in one of the meetings you could tell our children, aged
Yes.
from class 6 to class 12,
Yep.
we are inviting into this group only from class 6 to class
Plus
12.
12. Yep.
So if in what way AI can help them to improve their studies and all that?
100%. Yes.
So if you could tell us, maybe make a small presentation kind of things which will help
Yep.
them, it would be nice. And of course, it will be nice for older people like me also.
For sure. For sure. Yeah. Yeah. Now, most recently, they have come up with something called personal agents. So there is this software called AI called OpenClaw AI. So you can host it in one of your chat services like WhatsApp or Telegram, because it needs an interface to talk to you, and you give it access, and you host it in AWS, and you give it access to your system. You can talk to it like a personal agent, like clean up my computer, like arrange my
I
folders,
have a
book a ticket
question.
for me, check in a flight for me. It just needs to know the ID and password, and it will do everything for you. So that is where we have come to nowadays. So,
Yeah, it will be great if we can help our
uh
children and us too how to
yes,
use
yes.
effectively the AI. Or maybe if you want next time, next Saturday, can we do this?
I'll try. Like I have a really busy schedule going on in the
Okay, then you
office.
can,
I'll
when you
keep.
are comfortable, it's
Yes, yes.
okay.
I'll
I
I'll
can,
keep
yeah.
you posted. I'll keep everyone posted here.
Okay, okay. It's very
Okay,
nice.
okay, can I
Okay.
add one thing? Last time someone had asked a question regarding storm in Madagascar. Why doesn't strong storm happens? I looked at it later. The only reason is it's not in the news. The storm at Madagascar is as strong as the storm hurricanes in Florida. The only thing is Florida gets flashed all over the place. Madagascar does not happen. So the
Oh, I
set of
see.
conditions being similar, things happen.
Oh, I see. That's very nice.
Yes, sir.
So,
Saksham had asked that question.
Yeah, so I
so
checked up on the internet later on, and the conditions are similar. Here also, from the desert from Australia, it's picked up, water is picked up, travels a long distance, and does the same damage to Madagascar, even more damage to Madagascar because of poor infrastructure as compared to Florida or Georgia in US.
Uh, okay.
and recently, there is one question which is coming up everywhere. I saw in the newspaper today that it seems Trump has withdrawn all the that green gases don't affect us. So the temperature anyway is going to increase, the Earth's temperature. Then what is going to happen after say 100 years? So maybe we can discuss it next time.
Yes. So someone has raised his hand, Earth.
Or is it we discuss it now or next time?
Sorry, someone has raised his hand. I think so.
Acha, Earth, what is the question you have?
So, why do our hands get warm when we rub it?
Why does our when we rub it? Oh, it's
Why
because
do
of
our
friction.
hand get warm when we rub them?
Yeah, it's because of friction. Friction only.
Yes,
So,
sir.
why it get warm?
Yeah, because friction causes heat, so your hand gets warm.
Okay, sir. So I have another question.
Yeah. Okay. Let this be the last question today.
Okay, sir. So
Yes.
why do athletes wear shoes with its spikes?
Sir,
Yeah.
maybe
Who?
sir, maybe that provides grip on the field so that they don't slip.
I didn't understand your question. What is your question?
No,
Why
he's
do
saying that
athletes
the sportsmen know they wear shoes in which the spikes are there in the sole.
yes, sir,
So
like
why
it
it is there?
like it spike?
Hmm.
Yeah, one answer to me it looks what Aryan has said.
Sir,
Yeah, it gives a grip on this one, right?
Yes, because of the grasses, the spikes are very important to make a grip on them. Because,
Right.
because due to
Like
the normal shoes, there is a high
in
chance to slip.
Olympic, the racer use only the track are already made up of rubber. Then they get grip on there. So why they wear a spike too also?
can you repeat?
Like in Olympic, the tracks are already made up of rubber that has grip. So why do athletes there also wear shoes with spikes?
To get extra grip, they don't want to fall, no?
Yes, if they got mistakenly slipped, then due to these spikes, they won't be.
Okay, nice question. I think it never occurred to me, but I got the answer also from you all. So now we say bye bye to everyone.
Okay, sir.
Bye, sir.
Bye,
Have a
sir.
nice
Bye,
weekend
sir.